According to the National Electrical Code, the metal undercarriage of trailers can be used as a grounding electrode if it meets specific requirements. Firstly, it must be permanent and continuous. The undercarriage must be permanently and continuously connected to the electrical system, with no discontinuities. Secondly, it must be protected from corrosion. The undercarriage must be protected from corrosion to ensure reliable grounding connection. Thirdly, it must have low resistance. The undercarriage must have a low resistance to earth. To ground the antennas and antenna masts safely and effectively, 1. Verify the grounding electrode. Ensure that the metal undercarriage meets the National Electrical Code requirements for a grounding electrode. 2. Attach a grounding bar. Bolt a grounding bar to the metal undercarriage using stainless steel bolts and washers. 3. Install ground wire. Run a copper or aluminum grounding wire, minimum 6 American wire gauge, from the grounding bar to the antenna ground terminals. 4. Connect antenna masts. Ground the antenna mast by using a grounding braid or strap that connects the mast to the grounding bar. 5. Bond antennas to the mast. Bond the antennas to the antenna mast using a short piece of grounding wire. 6. Corrosion protection. Apply a protective coating, such as grease or sealant, to all bolted connections and exposed grounding wires. Use stainless steel hardware to prevent corrosion. Install grounding lugs within enclosures or protect them from weather and debris. Test the grounding system regularly using a ground resistance tester. To ensure an effective grounding system, the resistance to earth should be measured. This can be done using a ground resistance tester. The National Electrical Code recommends a resistance of less than 25 ohms for grounding electrodes. While the metal undercarriage can provide a suitable ground, it's important to note that it may not be sufficient for all applications. If the site experiences electrical surges or lightning strikes, additional grounding measures may be necessary. The grounding electrode system is a critical component of any electrical installation, ensuring safety and proper operation of equipment. The National Electrical Code, specifically Articles 250.50 through 250.70, outlines the requirements for grounding electrodes. Common types include metal underground water pipes, metal frames of buildings or structures, concrete encased electrodes, ground rings, and rod and pipe electrodes. Each type has specific installation requirements and suitability considerations. For example, a metal underground water pipe must have a continuous metallic path to the building service equipment and must be supplemented by an additional electrode. The metal frame of a building can serve as a grounding electrode if it is effectively grounded. Concrete encased electrodes, also known as UFA grounds, consist of at least 20 feet of bare copper conductor encased within concrete foundations or footings. Ground rings are bare copper conductors encircling the building or structure, buried at a specified depth. Rod and pipe electrodes must meet minimum length and diameter requirements and be driven into the ground to a certain depth. In addition to the type of grounding electrode, proper installation techniques are essential for ensuring effective grounding. All connections must be made using approved methods and materials such as exothermic welding, listed pressure connectors, or listed clamps. The grounding electrode conductor, which connects the grounding electrode to the electrical system, must be sized appropriately based on the size of the service entrance conductors. Protection against physical damage is also important, particularly for exposed grounding electrode conductors. Regular inspection and testing of the grounding electrode system are recommended to verify its integrity and effectiveness. Ground resistance testing, as previously mentioned, can help identify potential issues with the grounding electrode, such as corrosion or loose connections. If the resistance exceeds acceptable limits, corrective action should be taken to improve the grounding system. In mobile or transportable structures, such as the construction trailers in question, the grounding requirements may differ slightly from those for permanent buildings. The National Electrical Code Article 550 addresses the specific requirements for mobile homes, manufactured homes, and recreational vehicles. These structures typically have a grounding system that includes a grounding electrode conductor connected to a grounding busbar within the main panel. The metal chassis or frame of the structure is often bonded to this grounding bus bar. When connecting the mobile or transportable structure to an external power source, such as a service panel at the construction site, it is important to ensure that the grounding electrode system is properly connected. This may involve installing a grounding electrode, such as a ground rod, and connecting it to the grounding busbar within the structure. It is also important to verify that the neutral conductor is properly isolated from the grounding conductor except at the main service entrance. In situations where multiple mobile or transportable structures are located in close proximity, it may be necessary to coordinate the grounding systems to avoid potential ground loops for circulating currents. This can be achieved by bonding the grounding systems of the individual structures together, creating a common grounding network. The size of the bonding conductors should be sufficient to carry any fault current that may occur. Another important consideration for grounding antennas and antenna masts is lightning protection. Antennas and masts are particularly susceptible to lightning strikes, which can cause significant damage to equipment and pose a safety hazard to personnel. The National Electrical Code Article 810 addresses the specific requirements for lightning protection of antennas and masts. These requirements include installing lightning arresters, grounding the antenna mast, and bonding all metallic components together. Lightning arresters are devices that divert lightning current to ground, protecting the equipment connected to the antenna. The grounding conductor for the antenna mast should be sized appropriately and connected to a grounding electrode system that meets the requirements of the National Electrical Code. All metallic components, such as the antenna, mast, and coaxial cable shield, should be bonded together to minimize potential differences and prevent arcing. In addition to the National Electrical Code, other standards and guidelines may be applicable to the grounding of antennas and antenna masts depending on the specific application and location. These may include industry standards, local codes, and manufacturers' recommendations. It is important to consult all applicable standards and guidelines to ensure that the grounding system is designed and installed properly. Proper grounding is essential for the safe and reliable operation of electrical and electronic equipment. By following the requirements of the National Electrical Code and other applicable standards, it is possible to create a grounding system that protects equipment and personnel from electrical hazards. In the specific scenario of grounding antennas on construction trailer undercarriages, careful attention should be paid to the condition of the undercarriage, the quality of the connections, and the overall resistance to earth. Regular inspection and testing of the grounding system are essential to verify its integrity and effectiveness. Remember that electrical work can be dangerous, and it is always recommended to consult with a qualified electrician or electrical engineer when designing and installing a grounding system. Their expertise can help ensure that the grounding system meets all applicable requirements and provides adequate protection against electrical hazards. When choosing a grounding wire size, several factors must be considered to ensure it can safely handle potential fault currents. The National Electrical Code provides guidelines for selecting the appropriate size based on the overcurrent protection device protecting the circuit. Typically, the grounding electrode conductor is sized based on the size of the service entrance conductors. For example, if the service entrance conductors are 2 American wire gauge copper, the grounding electrode conductor should be at least 8 American wire gauge copper. However, the size may need to be larger depending on the specific installation requirements and local codes. The material of the grounding wire also affects its ampacity. Copper is a better conductor than aluminum, so for the same ampacity, an aluminum wire needs to be larger than a copper wire. The National Electrical Code provides tables that list the ampacity of different wire sizes and materials. When connecting the grounding wire to the grounding bar or other grounding electrode, it is important to use appropriate connectors. These connectors should be listed for grounding purposes and compatible with the wire size and material. The connection should be made tightly to ensure a low resistance path for fault currents. Regularly inspecting the grounding connections for corrosion or damage is essential to maintain their effectiveness. Corrosion can increase the resistance of the connection, reducing its ability to carry fault currents. If corrosion is present, the connection should be cleaned and retightened or replaced if necessary. In addition to the grounding wire, other components of the grounding system, such as the grounding bar and grounding electrodes, also need to be properly sized and installed. The grounding bar should be large enough to accommodate all of the grounding wires and equipment grounding conductors. The grounding electrode should be installed according to the National Electrical Code requirements to ensure a low resistance path to earth. Regular maintenance of the grounding system is essential to ensure its continued effectiveness. This includes inspecting the grounding wires, connections, grounding bar, and grounding electrodes for any signs of damage or corrosion. Ground resistance testing should also be performed periodically to verify that the grounding system is still providing a low resistance path to earth. If the ground resistance is too high, corrective actions should be taken to improve the grounding system. These actions may include adding additional grounding electrodes, improving the connections, or replacing damaged components. In addition to the equipment grounding system, there is also a personnel grounding system that is designed to protect workers from electric shock. The personnel grounding system typically consists of grounding mats or straps that are connected to a common ground point. Workers can then wear conductive shoes or wrist straps that are also connected to the common ground point. This creates a low resistance path for any fault current to flow to ground, reducing the risk of electric shock. Proper grounding is essential for the safe and reliable operation of electrical equipment. By following the National Electrical Code requirements and best practices, it is possible to create a grounding system that protects equipment and personnel from electrical hazards. Always consult with a qualified electrician or electrical engineer when designing and installing a grounding system.